Imagine a computer that could do almost everything that we could think of, that has the power of hundreds of thousands of supercomputers combined. This revolutionary computer is called the quantum computer. Before we get into quantum computers any further, we first have to understand the quantum world. This is a world made up of tiny things which are smaller than Lego blocks, smaller than molecules, and even smaller than atoms. See, these subatomic particles are really weird. They sometimes act as particles, sometimes act as waves. We can figure out their velocity and their position, but not at the same time. What? Because these particles are so weird, we can only guess what they are doing. They could be biking, swimming, or hiking. Lucky for us, we have probabilities of each activities that the particles might be doing. So they have a 35% chance of biking, 10% of swimming, or 55% of hiking. Using these probabilities, we can create a graph that looks like this, where the higher the graph is, the more likely they are doing the activity. We can basically simplify these types of graphs to what's known as the wave probability function, and figure out the options that are more likely than others. Now, before we check what these particles are up to, all the choices of activities are overlapped, meaning that before we check, they are biking, swimming, and hiking all at the same time. This is called quantum superposition. So how do you use this quantum superposition to make a quantum computer? In a normal computer, there's something called the CPU, which is basically the brain of the computer, and the CPU is made up of bits. These bits store and compute values using the binary scale, which only uses 0 or 1 to store data. Each bit is like a placeholder for more combinations of 0 and 1. One bit has one placeholder and can have 0 or 1, so there are two possible values. Two bits have two placeholders and can have 00, 01, 10, or 11, so there are four possible values. As the number of bits increases, the number of the values that they can store or compute exponentially increases. However, bits can only calculate one possibility at a time. On the other hand, quantum computers have quantum bits, or qubits. These qubits use quantum superposition to have an overlap condition of 0 and 1, allowing them to calculate all the possible values at the same time. This makes quantum computers way faster than the normal computers that use bits. Quantum computers are also really good at optimizing and modeling solutions because they can go through all the options at the same time. This allows us to solve problems or run virtual experiments that would be impossible for normal computers. The quantum computer is not just an upgrade from our supercomputer. It may be the key to a new generation of technology.